Okay, so now let's try to mix some of our rules. So first of all, we need to be able to look at a function and determine which rule applies. What do I use? So let's look at these four functions that are written and determine which is a composite function, meaning which one has the fundamental operation as composition, meaning that if you are going to input some value for the variable, which one would the very last step be composition? Not somewhere in the middle, the very last step. So pause and see if you can figure it out for yourself. Okay, so I'm going to do it now. If I look at f of x and ask if I put x in, what would be the very last thing I would do? So I would compute sine of x, and I would compute cosine of x, and the very last thing I would do would be to multiply them together. So if I see that this function, and I wanted to take the derivative, I would say the fundamental operation is multiplication. So I would want to start with the product rule. So composition is not this one. So let's cross that one out. Okay, so let's look at g of w. If I were going to input a value for w, I'd figure out what 3w squared times 7 to the w was. I'd figure out what the square root of 11w is, and then I would add them together. So since addition is the fundamental operation here, we would use the sum rule, where the sum of two, the derivative of the sum of two functions is the sum of the derivatives. I'd have to find each derivative separately. Even though the square root of 11w is a composition, you might have said that, then that's true. So in the middle of finding the derivative of g, you would have to use the chain rule, but it would not be what you start with. So that's not the answer here. Let's look at h of r. If you are going to input a value for r, you'd figure out what r squared is. You'd figure out what sine of r is. You'd multiply them together, and then you would take that answer and take the square root of it. Okay, you would take that answer and then take the square root of it. So you take the answer from one function and input it into another function. So that right there sounds like composition. So h of r is definitely a composite function, and we want to use the chain rule for it. Okay, let's look at k of t. K of t, if I were going to put a t value in, I'd figure out 45 times 2 to the t, figure out the answer to this guy, and figure out e to the square root of t, and figure out this guy, and then I would divide those two answers. Division would be my very last step, and so since division is the last step, that means the fundamental operation here is division, and so I would start with the quotient rule. Okay, since I'd start with the quotient rule, this guy is not a composite function.